Hi everyone. Happy Earth Day. And it's such a great day. Here's a picture I took of me and my dog today. I'm wearing these funky glasses, and those are actually so I can see the computer without eye strain. So you can get those $5 on Amazon if you're getting too much eye strain. So happy Earth Day, everyone. So as we look at Earth Day, let's talk about what things could happen to the Earth. An asteroid might hit the Earth, who knows? Okay, you're going to learn about asteroids and what's happening with them and how people are looking to save our lives and our world from them. So today, what you're going to do is you're going to do slides 20 through 34. So if you're watching this video, you don't have to go through the slides, but there are some videos that you will have to look at that are on the slides. So I have some news for you. This happened a couple of years ago. Headline: what happened is Pluto was demoted. It is no longer a planet. It used to be considered a planet until 2006. And boy, when I was teaching in 2006, the students couldn't believe it. But it's not a planet anymore. The International Astronomical Union defined a planet as a body that orbits the sun, which Pluto does. It's spherical and it's large enough to clear its orbit. Well, they reclassified Pluto as a dwarf planet because it's not large enough to clear a path around its orbit. Now, to clear its own orbit means a planet has to become gravitationally dominant, and there are no other bodies of comparable sizes other than its own satellites, or those otherwise under its own gravitational influence. Now, Pluto has some moons, but the moons are actually about the same size. So that's one of the reasons it hasn't cleared it. And another thing, too, if you noticed with the planetary sheets and some of the different slides before, Pluto has a weird orbit. So again, it will cross the orbit of Neptune sometimes, and then it's not really on the same plane as the other planets. So there's something weird about it, okay? So the next slide that I have is going to talk about what a satellite is, okay? Now, a satellite is a body that revolves around a planet. Now, this could be natural, like a planet's moon, or they can be man-made, like communication satellites. Now, there are these satellites that are always, there's a whole bunch of them in past our gravitational pull that are used for cell phones, used for satellite phones, that are used for weather, that take a lot of data. And those are considered satellites because they will orbit our Earth due to gravitational pull. But a moon is also considered a satellite. So let's look at what a moon is. Now, a moon is a natural satellite, and every single planet in our solar system, except Mercury and Venus, has at least one natural satellite or moon. And a moon is a body or that orbits a planet. Now, you guys should have noticed this. There are a total of about approximately 166 moons in our solar system, or satellites, and that's a lot. And you guys should have seen this pattern in the planetary sheet that you guys did on Wednesday, I believe it was yesterday, or no, Tuesday. Now, again, the closer you get to the sun, the planets have very few moons. So there's kind of like these cool patterns. Earth has one moon, Mars has two, and then we notice that the gas giants have a lot. But what's interesting with the gas giants, the larger the planet, the more moons it tends to have. Do you see that? So Saturn has a little less, Uranus has less, and Neptune has the least. So it's an interesting pattern, and I'm hoping some of you guys are finding awe in the patterns of our solar system. There's so many cool patterns. Okay, so now here's a picture of some of the many moons in our solar system. they all, they're very similar, all have craters. Some moons have an atmosphere, most moons do not. My favorite moon is Io, which is a moon of Jupiter, and there's a lot of volcanic activity on Io, and so it kind of looks like a rotten orange, a really cool rotten orange. Okay, now this slide here has the moons of our solar system scaled to the Earth's moons. Okay, so this is Earth's moon right here. And Mars, look at the moons of Mars. So if you were going to go to Mars, the moons of Mars aren't going to be like the Earth moons. You're not going to have the same kind of monthly flow. You're not going to see a lot of ambient light. Now Io and our moon are about the same. So these are Jupiter's moons. And it looks like, some of them are slightly bigger than the Earth's moons. Now, Saturn has a lot of smaller moons than our Earth's moons. Titan is a huge moon of Saturn, and the rest of them are kind of small. Uranus, their moons are all smaller than the Earth's, and Neptune's moons tend to be a little smaller. Now, Pluto has its own moon, and it's called Charon, and its moon is actually kind of like very similar in size to Pluto. A little smaller, but not that much. Okay, so I just wanted to show you the relative sizes of the moons. Now let's go ahead and talk about planet rings, okay? Now, all the inner planets don't have rings. You guys should have noticed that the gas giants all have rings, although some of them are pretty faint. And now the planet rings are made of tiny bits of dust, ice, crystals, and small pieces of rock. There's an acronym called RID, rock, ice, and dust, to kind of describe what it is. And if you noticed with the planetary data sheet, the bigger the planet, the more rings it had. So it's kind of cool, another pattern. And scientists kind of they think about the development of our solar system based on these patterns. So here is a beautiful picture of Saturn's rings. And then I want you to look at the slides. Do these planet rings move? And when you look at these slides, you're going to see that these move also counterclockwise, the same direction that the planets move. It's kind of cool. Okay, so let's talk about those asteroids and the asteroid belt in our solar system. Now, asteroids are small rocky objects that move around the sun, and guess what direction they move? Counterclockwise. The same direction as all the planets move. Now, most of them are scattered in a large area between the orbits of Mars and Jupiter, and that's called the asteroid belt. Now, they rarely move through other parts of the solar system. Once in a while, they'll get knocked out, but these tend to move in its own orbit. Okay? Now, there are also asteroids that orbit other asteroids. And if you look at the slide, you'll see an animation of these two. Because they're very similar, they have the same kind of gravitational attraction, and they go around in circles. It's really cool. Okay, so let's look at where these are. Okay, so here's the sun, and here is Mars, and here is Jupiter. So again, those asteroids orbit between Mars and Jupiter. Now, there's several theories about why we have asteroids, and one of them is that when the solar system was developing, that maybe there was not enough energy in this area of the solar system for the gases and material to form a planet. Some people think that, maybe there was a planet and it got destroyed, but what's interesting is the question is, why then are there asteroids here? Because there's such a big difference. So it's an interesting area of our solar system. Okay, so here's some pictures of asteroids. Now, most of them are irregular shapes, and all asteroids have a name. And again, Phoebus is one of the one of the moons. I'm trying to remember what planet. I can't remember off the top of my head. But sometimes some people believe that sometimes a moon has been a captured asteroid. But a lot of them are irregular in shape. They are not spherical. Now there's a video here called The Asteroid Belt. Not What You Think. Please watch that. It's very fascinating. And then you're going to do your assignment. Now, the assignment for today is the Astronomy Doodle Notes. And what you're going to notice is there's a blank page. And what I want you to do is you're going to color it. Here's the answer key. Just take this information and actually write it on this in your own words. If you want to print this out and color it, that's fine. But again, I want all the information that's on this page to be on this page. And then you're going to turn it into today's Google Classroom. Well, have a good Earth Day, and I can't wait to give you a lesson for tomorrow. Bye.